Hey guys, so if you've been watching this segment of videos where I talk about composition of functions and inverse functions, with composition functions I dedicated that one to the blog. With inverse functions I never really dedicated them to anyone except maybe Girl Scouts. I can't remember what I've done now. You might be wondering, well, what do the two have to do together? Compositions and inverse functions. Well, funny you should ask. I'm sure you really asked, huh? All right, so let's show that if f of x equals 2x minus 5, then the f inverse of x equals x plus 5 over 2. Let's form a composition here. Let's take our f, compose f inverse of x, and let's see what happens here. So if you remember composition of functions, we work from the inside out, so we're going to take our f inverse here, our x plus 5 over 2, and we're going to put it in for that x right there. So this x is gone, and an x plus 5 over 2 takes its place. So I've got 2 times the quantity of x plus 5 over 2 minus the 5. Well, hopefully you're noticing already that these 2's will divide out, and that gives us x plus 5 minus 5. And you just get x. Well, that's interesting. Let's go in reverse and see what happens. I could go f inverse of f of x. So now I'm going to go in exact opposite. I'm going to take the 2x minus 5 there, and I'm going to put it in for this x in the f of inverse function. So I'll have 2x minus 5 plus the 5 over the 2 there, and then we'll simplify. Negative 5 plus 5, that drops out, so I just have 2x over 2, and the 2's drop out. I get x again. What? Yeah, that's what they need here. To show that one function is an inverse of the other one, you compose them. You stick one inside the other one, and if your result is x, then you know you've got one function as an inverse of another one. So that's why they talk about composition of functions right before they talk about inverse of functions in intermediate algebra textbooks, because they do tie in really well together, and that's why. Okay. Now, why do they even talk about inverse functions and compositions? Well, I talked about why they use compositions, but why do they talk about inverses right before they talk about exponential functions and logarithms? Well, I'll probably bring this up in a future video, but with an exponential function, which is what's coming up next, an exponential function is an inverse of a logarithm, and vice versa. A logarithm is an inverse of an exponential function. Cool, huh? We're going to talk about all that down the line, but for right now, that's it.